Alright, so we're going to start working on polyatomic ionic bonds. And let me get on to the slideshow over here. And so those are a little bit different than binary ionic bonds. So just as a way to remember, binary is where you have, let me get my pen on here. There we go. Binary is when you have NaCl. We have two different elements. So here is sodium, and here we have chlorine. So we call those binary because there are two different elements, okay? But when we're talking about polyatomic ions, we have more than two. So you would have something that perhaps would look like this, NaOH. And just to remember, if it has a capital letter, that it's the start of a new element. So in this case, we have sodium, we have oxygen, and we have hydrogen. So we have 1, 2, 3 different elements. In that case, we call it polyatomic. So for poly meaning many ions. All right? So they have their own rules, and we're going to go through what those rules, how those rules actually work. And this will be on your white piece of paper. We have divided it into 5 groups, and this is going to be what we call ionic bond type 3. Okay, and a good way to remember it is that often you have 3 different elements, and so it is type 3 as well. So let me go ahead and erase this screen and break down how this works out. So in class, I gave you a handout where you had a list of all the transition elements such as copper and mercury and iron that come with different oxidation numbers, and just below that you have a whole list of the polyatomic ions. And just for your information, you actually have that in your book as well on page 100, and it's table 4.4. All right, so the way that I want you to sort of look at polyatomic ions is it's sort of like a clique of students who just hang out together and are their own personality. So you might have the clique of students that's more the theater students that just do a lot of theater, or it could be the clique of athletic students who particularly maybe the football players. So they all sort of, when they come together, they have an identity of their own. And so polyatomic ions are the same sort of thing. So for example, we'll use nitrate as an example. Nitrate, if you look at your piece of paper, has the chemical formula of NO3 with a negative charge. That means when these elements come together, they always have a -1 charge. And we consider that sort of one entity. So if a nitrate were to come together with perhaps a potassium, so if we have potassium and nitrate coming together, this is what that would look like. So potassium, remember, is K. It has 1 electron. In other words, it has a positive charge. And we know that nitrate, NO3, has a negative charge. When they come together, that positive and that negative balance out to have a 0 charge. So you would place them together as a 1-to-1 ratio, and this is called potassium nitrate. Okay, so that's the easy one, but sometimes it's not quite so simple with the charges, and so let's work through some of those problems on the next screen over here. All right, so let's try sodium sulfate. Okay, we have sodium coming together, and we have sulfate. So the way that I remember it, usually if it has a T, think of like T stands for 3. They both that 3 starts with the letter T. So that means you have 3 elements. We know that this one is going to be polyatomic because of that T being a giveaway. So I now look at my table and I see that sulfate is SO4 with a 2 negative charge. Okay? So this is something I got from the table. Sodium, on the other hand, if I look at my periodic table, so now I'm going to be using both of them, sodium, on the other hand, is considered an alkali metal. And because it is an alkali metal, that means it has a positive charge. So in this case, if I add these two together, we have a plus charge and a -2 charge. They're not going to equal 0. So we have to sort of deal with them the same way that we deal with any sort of binary ionic compound. And so that sort of lets me go, okay, well, if I give it another sodium, now I have a total of +2 and have that work out with the -2, and that does equal 0. So in that case, I would have the chemical formula of sodium with a small subscript of 2, SO4. Okay, I don't put up any charges because they are now equaled 0. So I don't put any charges up here. And this is called sodium sulfate. All right, so let's try perhaps another one. I'll go ahead and clear the screen here. So let's do the last one that we're going to work on is manganese oxide. So we have manganese and then hydroxide. My apologies, hydroxide. So this is one of those unusual ones where it does actually end with an IDE that could throw you off, but it is in fact a polyatomic ion. And if I look on my table, it has the chemical formula of OH with a minus. Manganese is Mn, and if I look at its periodic table, this one has a +2 charge, okay? Because that's an alkali earth metal. So now if I add these two together, clearly they're not going to equal 0 because I have a +2 here and -1 over here. So I need to make them equal to 0, and I can do that by giving this another hydroxide. So if I give it one more, we have another -1, and so that would work out with our charges +2 +2 -1, because I have 2 -1s, which equals 0. So that means that for every manganese, I have to have 2 hydroxide. And there's a special way of writing it. You put parentheses there, and then a subscript of 2. So this is considered manganese hydroxide, just as the name says. And that's the end.